Hi, this is Mr. Beanmat and I'm going to discuss to you about arithmetic sequence. Our objectives: in this learning video, students will be able to illustrate an arithmetic sequence and determine arithmetic means and end term of an arithmetic sequence. On my first video, I discussed about sequence and how to generate patterns. Now let's have some review on what we've learned from my previous tutorial. Can you tell what's the next shape? Yes, it's pentagon. How about this? Can you tell what's the next pattern? Yes, it's the same as the first. So what's the next letter? Of course, it's the letter J. And what's next to 35? The answer is 42 because the sequence is in multiples of 7. And what's next to negative 54? The answer is negative 45 because the sequence has a common difference of 9. Now let's define arithmetic sequence. Arithmetic sequence is a sequence wherein succeeding terms are obtained by adding a fixed number called common difference. So to find the next terms in an arithmetic sequence, we use the formula a sub n equals a sub 1 plus d times quantity n minus 1, where a sub n is equal to last n term, a sub 1 is equal to first term, and n is equal to number of terms in the arithmetic sequence. Now, let's try some examples and tell whether the given sets are arithmetic sequence or not. In our first example, the arithmetic sequence given are 12, 10, 8, 6, 4, and so on. Is it AS or not? Well, let's try to take any term and subtract the preceding term. 12 minus 10 equals 2, 10 minus 8 equals 2, 8 minus 6 equals 2, 6 minus 4 equals 2. Notice that the difference is always 2, so therefore the answer is AS. 2, 3, 5, 6, 8, and so on. Is it AS or not? It's not because it has no common difference. Negative 10, negative 20, negative 30, negative 40, and so on. Can you guess the answer? It's AS because it has common difference 10. Negative 2.2, negative 3.3, negative 4.4, negative 5.5, and so on. Its AS and its common difference is 1.1. 19, 28, 37, 46, 55. Yes, it's AS because its common difference is 9. Negative 5, negative 5, negative 7, negative 7, and negative 11. Yes, it's not AS because it has no common difference. 7, 4, 1, 2, 5, and so on. Yes, it's not AS because it has no common difference. 1, 4, 9, 25, and 36. Yes, it's not AS because it has no common difference. Negative 25, negative 9, negative 4, negative 1, and so on. Yes, it's not AS. 1/2, 1/3, 1/4, and 1/5. Obviously, it's not also AS because it has no common difference. Now let's discuss the nth term of the arithmetic sequence. What is the nth term of an AS? To find the nth term in an AS, we use the formula a sub n equals a sub 1 plus d times quantity n minus 1. Now let's have an example. Find the ninth term of the sequence 6, 9, 12, 15, and so on. So our a sub n is equal to a sub 9, or the ninth term, a sub 1 or the first term is 6, d or the common difference is 3, and n is 9. Now let's substitute using the given formula. So a sub 9 equals 6 plus 3 times quantity 9 minus 1. A sub 9 equals 6 plus 3 times 8. A sub 9 equals 6 plus 24. And a sub 9 equals 30. Therefore, a sub 9 equals 30, the ninth term in the AS. Now, let's try more examples. What is the 12th term? 8, 12, 16, 20, and so on, where a sub n equals a sub 12, a sub 1 equals 8, b equals 4, and n is equal to 12. Using the formula, a sub 12 equals 8 plus 4 times 12 minus 1, a sub 12 equals 8 plus 4 times 11, a sub 12 equals 8 plus 44. Therefore, a sub 12 is equal to 52. A sub 12 is equal to 52, the 12th term in the AS. What is the 16th term? So, negative 15, negative 20, negative 25, negative 30, and so on, where a sub n equals a sub 16, a sub 21 equals negative 15, d equals negative 5, and n equals 16. Using the formula, a sub 16 equals negative 15 minus 5 times quantity 16 minus 1, a sub 16 equals negative 15 minus 5 times 15, a sub 16 equals negative 15 minus 75, and therefore a16 equals negative 90, the 16th term in the AS. What is the 21st term? 32, 30, 28, 26, and so on, where a sub n equals a sub 21, a sub 1 equals a sub 32, d equals negative 2, and n is equal to 21. So using the formula, a sub 21 equals 32 minus 2 times quantity 21 minus 1. A sub 21 equals 32 minus 2 times 20. A sub 21 equals 32 minus 40. Therefore, a sub 21 equals negative 8, the 21st term in the AS. What is the 32nd term? 0, negative 8, negative 16, negative 32, and so on, where a sub n equals a sub 32, a sub 1 is equal to 0, d equals negative 8, and n is equal to 32. Using the formula, a sub 32 equals 0, minus 8 times quantity 32 minus 1, a sub 32 equals 0 minus 8 times 31, a sub 32 equals 0 minus 248. Therefore, a sub 32 equals negative 248, the 32nd term in the AS. Now, let's discuss how to find the arithmetic mean of an arithmetic sequence. First, let's define arithmetic mean. These are terms between any two non-consecutive terms of an AS. To find the AMs, we use the formula a sub n equals a sub 1 plus d times quantity n minus 1 and solve for the d. Let's have an example. Insert two AMs between 6 and 15. Since we must insert two numbers between 6 and 15, there are four numbers in the arithmetic sequence. Thus, a sub n is equal to a sub 4. A sub 4 is equal to 15, which is the last term. A sub 1 is equal to 6, which is the first term. And n is equal to 4, which means the number in arithmetic sequence. We can solve d using the formula a sub n equals a sub 1 plus d times quantity n minus 1. Thus, 15 equals 6 plus d times quantity 4 minus 1. 15 minus 6 equals d times 3. 9 equals 3d. 9 divided by 3 equals d. And 3 equals d. Hence, a sub 2 equals a sub 1 plus d equals 6 plus 3 equals 9. A sub 3 equals a sub 2 plus d equals 9 plus 3 equals 12. Therefore, the two arithmetic means between 6 and 15 are 9 and 12. Now let's try the following. For number 1, insert 3 AMs between 7 and 31. So there are 5 numbers in the arithmetic sequence. Thus, a sub n equals a sub 5, a sub 5 which is our last term 31, a sub 1 which is our first term 7, and n which is 5 or the total number in the arithmetic sequence. Now using the formula to solve d, 31 equals 7 plus d times 5 minus 1. 31 minus 7 equals d times 4. 24 equals 4d. 24 divided by 4 equals d. And 6 equals d. Hence, a sub 2 equals a sub 1 plus d equals 7 plus 6 equals 13. A sub 3 equals a sub 2 plus d equals 13 plus 6 equals 19, sorry. A sub 4 equals a sub 3 plus d equals 19 plus 6 equals 25. Therefore, the 3 AMs between 7 and 31 are 13, 19, and 25. For number 2, insert 2 AMs between negative 14 and negative 2. Since we must insert 2 numbers, there are 4 numbers in the arithmetic sequence. Thus, a sub n equals a sub 4, a sub 4 equals a sub 4 equals negative 2, a sub 1 equals negative 14, and n equals 4. So using the formula to solve d, negative 2 equals negative 40 plus d times quantity 4 minus 1 Negative 2 plus 14 equals d times 3. 12 equals 3d. 12 divided by 3 equals d. And 4 equals d. Hence, a sub 2 equals a sub 1 plus d equals negative 14 plus 4 equals negative 10. A sub 3 equals a sub 2 plus d equals negative 10 plus 4 equals negative 6. Therefore, the two AMs between negative 14 and negative 2 are negative 10 and negative 6. Number 4, insert 3 AMs between negative 3 and negative 43, so we have 5 numbers in the arithmetic sequence. Thus, a sub n equals a sub 5, a sub 5 equals negative 43, a sub 1 equals negative 3, and n equals 5. Using the formula to solve d, negative 43 equals negative 3 plus d times 5 minus 1. Negative 43 plus d negative 43 plus 3 equals d times 4. Negative 40 equals 4d. Negative 40 divided by 4 equals d. And negative 10 equals d. Hence, a sub 2 equals a sub 1 plus d equals negative 3 minus 10 equals negative 13. A sub 3 equals a sub 2 plus d equals negative 13 minus 10 equals negative 23. A sub 4 equals a sub 3 plus d equals negative 23 equals 10. Minus 10, equals negative 33. Therefore, the 3 AMs between negative 3 and negative 43 are negative 13, negative 23, and negative 33. And for our final example, insert 5 AMs between 16 and 88. So we have 7 numbers in the arithmetic sequence. A sub n equals a sub 7. A sub 7 equals 88. A sub 1 equals 16. And n is equal to 7. Using the formula, 88 equals 16 plus d times quantity 7 minus 1. 88 minus 16 equals d times 6. 72 equals 6d. 72 divided by 6 equals d. And 12 equals t. Hence, a sub 2 equals a sub 1 plus d equals 16 plus 12 equals 28. A sub 3 equals a sub 1 plus d equals 28 plus 12 equals 40. A sub 4 equals a sub 1 plus d equals 40 plus 12 equals 52. A sub 5 equals a sub 2 plus d equals 52 plus 12 equals 64. And a sub 6 equals a sub 3 plus d equals 64 plus 12 equals 76. Therefore, 5 AMs between 16 and 88 are 28, 40, 52, 64, and 76. Now that we've learned about arithmetic sequence, I would like to know your thoughts about this video by answering the following questions. Please like this video and don't forget to subscribe for more tutorials. Thank you for watching!